Welcome back. In previous lecture, we discussed the symbols for various hydraulic system components, like pump with motor, filters, oil tank, pressure regulator, check valve, and accumulator. In this lecture, we'll continue with the hydraulic symbols and we'll mainly discuss the valve symbols, which is one of the most important items in any hydraulic system. When we talk about valve, we need to have three main information in hand: position, port, and flow. Position relates to the movement or the action on the actuator created by activating the valve. The port means the connection to the valve, how many items connected to this valve. And flow simply explains the flow path of hydraulic oil within a hydraulic system. We'll have position symbols, port symbols, and flow symbols. Three of them will combine together to give me a valve symbol, and from that symbol I will be able to understand the main function of this valve. Let's start with position symbols. Position describes the action of hydraulic system actuator, whether extending, retracting, or off, no movement or no action, sometimes inclining, raising, lowering. So position, when it's coming in the valve, it describes the action of hydraulic actuator. In these two sketches, I have two samples of valve of 2 position and one is 3 position. Let's assume this is a lever or something I need to operate this valve. If I move it to the right side, it will make the piston within the cylinder to extend. If I move it to the left side, it will make the piston to retract. So only 2 positions here, either extend or retract. While for the 3 positions valve, I have now one new position which is off, neutral. It will not make any movement in the piston within the cylinder. And some of the applications I need to hold a weight, for example. So it should be the valve within this hydraulic system be a 3 position or including a position to hold the actuator. So this is in brief the position explanation for a valve. How the symbol will be? It will be in the shape of envelopes. So the basic valve symbol consisting of one or more envelopes. The number of envelopes used will represent the number of positions that the valve can be shifted or operated to a specific function of an actuator. 1 position, single envelope. 2 positions, 2 envelope, responsible for either retract or extend. 3 positions means the valve can either make the actuator retract or extend or neutral, no movement. When we talk about the valve ports, ports are the system connections to the valve. These valves connecting which item? In general, most of control valves have 4 ports, and these ports will be P, T, A, and B. P stands for pump, which means the inlet to this valve will come from the pump delivery. T stands for tank, where the drain of this valve will go to the tank. And I have A and B, we call them as working ports. A may be responsible for extend and B will be responsible for retract. So this is basic description of the valve ports. And if we go to the symbology, we'll find that we have 2-way, 3-way, 4-way, 6-way valves. So here we show the valve ports for attaching the working line. A valve with 2 ports is commonly referred as 2-way valve. So I have here one connection and here another connection. This is called 2-way valve. A valve with 3 ports, 3-way valve, 1, 2, 3. A valve with 4-way or 4 ports will have, we call it 4-way valves, 1, 2, 3, 4. 6-way, the same. Don't confuse with the two-position valve, same as two-way. As we said, the positions relates to actuator movement. The way relates to the connections to the valve. Valves can have as many as positions and ports as needed, but most commonly valves have 1 to 3 positions and ports from 2 to 6 ports or ways. For example, you can have a valve that has 2 positions responsible for extending or retracting a piston, but controls 3 cylinders, and such will have 3 ports, outlet or working ports. When we go to the flow samples, we can represent the hydraulic oil flow within a valve in various ways. For example, here we have the flow in one direction coming from this side to this side. We have flow in either direction. The flow can pass through the valve either from here or here. We have a parallel flow for multiple ports. This flow can move here and the other can go other side parallel to it. Crossed flow and blocked flow. Blocked flow is represented in this way. So these lines and arrows inside the envelopes are used to represent the flow paths and the direction between the ports. It will give me clear indication how the oil will flow within the valve. To which ports, for what action. For example, let's say we have a 4x3 valve. What this will mean? It means that the valve will have 4 ports, PTAB, pump tank, working port A, working port B, and 3 positions, retract, off, extend. Let's see these 3 sketches down. These 3 sketches telling me that this valve has 4 ports and the pump is connected directly to the tank. If you remember the open loop hydraulic system, we can have this information that the pump is directly connected to the tank and the 2 working ports are blocked, no movement of the cylinder. Then another sketch is telling me that the oil will flow from the pump going to the port B, which will be responsible for, let's say, retract, and the remaining fluid within the cylinder will be drained through the port A to the tank. In a similar way to the third sketch, the oil may flow from the pump, going to the pump port to the valve, and then moving through the valve to the port A, which will be responsible for extend. Then the remaining fluid in the cylinder will be drained through the port B to the tank. Let's see one good example to show you how the control valve will work in a hydraulic system. If you can see here, this valve with 4 ports, PTAB, and the oil will flow from the pump port to port A, responsible for doing an actuation for the cylinder. And the remaining will be drained through port B, going back to the tank. Now, if we move this lever to the other side, now we have the pump is giving the oil flow to the port B, and the port A will be connected back to the tank. This is how it will work, how the oil will flow between the ports of a valve. I think in the next few seconds the video will show me in details how the movement of the spool, we call it a spool, within the valve will be moving. So I hope it is clear. Let's just wait for a couple of seconds. Yeah, see, from A to D. Now he reversed it back again, and let's see here the movement. Let's assume that this is BA and PT. The oil is going from B to the T port, going to the tank, and it is pumped to A. Now the spool is moving inside the valve, which divert the flow from P to B port, and from A it will go back to the tank. So this is an actual demonstration of how the valve will work in a hydraulic system. Let's now see another example how we can read a valve sample. Let's see this simple. And this is a directional valve. Infinite positioning. How I know infinite positioning? I will find two parallel lines to the valve sample. And infinite positioning means that the valve can operate in any position. And we will come to know this one in detail in section 3 while go to the types of control valves. Now I have here 3 envelopes, which means the valve has 3 positions. And at the same time, this one, the port connections are drawn to the center or neutral positions. I have these are the port connections. Let's assume that this is A, B, tank, and pump. So the ports connection will be drawn to the center, and the arrows show the flow path and the direction of the flow. Now, let's see also another example how the 3-position valve will operate. This is a working ports A and B, and we can call it closed center. Why we call it closed center? Because the valve on the top is a closed center, because when the hold position, the center spool blocks all oil flow. There is no flow here. See, when the position is held in this one in the center, if we can see, all the ports are blocked. The second type is tandem center, where the middle valve is a tandem center, this one, and when in the hold position, port A and B are blocked, but the valve connects the pump to the tank. Now there is a connection from P to T. The third one, or the bottom valve, is an open center valve where it holds the spool connect to all parts to the tank. Now I have everything is connected between A, B, P, and T. So these another 3 examples for 3-position valve, how it works. And we came to the end of this lecture. It was quite long. I hope you get it useful. And thank you. See you next lecture.